All right, so this is chapter 2 assignment. First question. You are driving through town at 12 meters per second. When suddenly a ball rolls out in front of you, you apply the brake and begin decelerating at 3.5 meters per second square. Okay, how far do you travel before stopping? All right, so here what do we know? Here is V naught equal to 12.0 meters per second. A, decelerating. Okay, all right. A, ask you about, also you know stopping. Stopping means V equal to 0, right? Stopping, all right? Ask you about delta X. So this is very easy. We already know three quantities, right? So you can find any other quantities. So what do we use? We use this one, V squared equal to V naught squared plus 2A delta X, this equation. So delta X equal to V squared minus V naught squared divided by 2A, right? Just this equation move around, and then equal to 0 squared minus 12.0 squared divided by 2, negative 3.5. Okay, so top is 144, bottom is, top is negative 144, negative 7.0, so this is 20.6 meter. Second, what is the speed of your car when you have traveled half the distance? Okay, so there's a total different question, right? So half a distance, so here no is displacement equal to half of this. So 20.6 divided by 2 equal to 10.3 meter per second, meter. Okay, and then what's our speed? So here you can use the same this equation, right? So you can figure the V squared equal to V naught 12.0 squared plus 2 negative 3.5. This is displacement 10.3, right? So whatever it is, so just calculate this out. 144 minus 2, so actually it's negative sign here, so minus, right? 7 times 10.3, 72.1, right? Okay, so, and then calculate this out, about 72, right? And calculate this out. So V equal to square root of this, 144 minus 72.1. Okay, so calculate this. So that is your speed when you finish half of the distance. All right, second one, you jog at 9.1 kilometer per hour for 5.0 kilometer. Okay, so what do you know here? This. So this is distance here is 5.0 kilometer. You use 9.1 kilometer per hour. Then you jump onto a car and drive an additional 13 kilometer. Okay, 13 kilometer with what average speed? Okay, so you don't know. Average speed must you drive your car if you average speed for the entire trip 18 kilometer is to be 25. Okay, so what do we know here? This for this whole trip, right? Average equal to 25 kilometer per hour. And then the first segment is 9.1 kilometer per hour. So looking for this one segment. So V2 average, right? So this is V1. This is V2. All right. Based on the equation of average velocity. So average velocity equal to distance over time, right? Okay, however, this distance, you have two segments. This is D1, D2. D1 plus D2 divided by time. Okay, so in this segment, we know this is average speed and this is distance, right? Then we can figure out time. Time equal to distance over average speed, right? So T1, so this segment is T1, okay? T1 plus T2, right? So first one is 5 plus second one is 13. T1, actually, you can use this equation, right? So this is 5.0, 9.1, and T2, we don't know T2, 13 divided by V2, right? And the whole average speed of the whole trip equal to 25. Okay, so you solve this equation, right? Okay, so top is 18 divided by 5.0, 9.1 plus 13 divided by V2 equal to 25. So you times this with the other side equation divided by 25, right? So 18, 25 equal to 5.0, 9.1 plus 13 divided by V2. All right, so next, move this to this side equation, right? So what you get here is, so 13 divided by V2 equal to 18, 25 minus 5.0, 9.1. Okay, so calculate this out, use your calculator, and then V2 go this side, then this whole thing go this side, right? So V2 equal to 13 divided by 18, 25 minus 5.0, 9.1. Okay, so that is your average speed for the second trip. So this is trip 1, trip 2, all right? All right, next one. An expectant father paces back and forth, producing the position versus the time graph shown below. Calculate the father's velocity for the segment ABCD. Okay, so this is position time graph. We know slope is the velocity, right? So it's a slope. You look at A, B, C, D. To find the slope on those segments, right? So slope from here, from a slope of A, this is a straight line. Slope here is, this is your velocity, okay? Slope is the velocity. So what's the slope? Slope here is, you see, rise here is 2, round here is 1, right? So 2 over 1. Oh, let's do this way. So the final position, right? So it's 2, initial position is 0, divided by, so final time is 1, 0. Okay, see, it's a 2. Well, 3 sig figure, okay? So this slope is 0. So this guy is, you see, rise here is 1. This is also 1. So this is a 1.00 meter per second, right? So this one you can tell final is 0, initial here is 3. So this one is 0 minus 3. This is 3 to 5, right? So 5 minus 3. So this is negative 1.50 meter per second, all right? So for position time graph, slope is your velocity time relationship. So what's the velocity? So you can draw the velocity time relationship. Here, yes, that's the velocity time, right? So you see from, this is 1 to 2, 2 to 3, 3 to 5, right? So y is 2 meter per second, 2 meter per second. Okay, and then became 0, then became 1 meter per second, right? Then became negative 1.5. Okay, so that is your velocity time graph. Okay, you see, this is 0, so this is 1.5, so this is, oh no, this is 1. Okay, the third segment is 1. Okay, so this is 1, or half of that. Okay, so this is negative 1.50. All right, so that's your position time. This is your velocity time graph. Meter per second. Second. All right. The position of a particle as a function of time is given by, okay, so here give you a, instead of give you a graph, give you a function. Find the average velocity of the particle between this time and that time. All right. So first, average velocity equal to final position, initial position divided by final time divided by initial time, right? So we have to know, we know final time is t equal to 0.45. We have to know what at this time, what is your position x2, okay? So just plug time into this equation, then you can figure out x2, right? So this equal to, so let me write here. So when time equal to 0.45 seconds, your position, okay, t2, x2 equal to, you see, just plug directly into this equation, 2.0 t 0.45 plus negative 3.0 t cube 0.45 cube. Okay, so this is x2. Then you can also figure out x1. This is time and what is x1, right? So let's directly plug into this equation, right? So x2 equal to 2.0, 0.45 plus negative 3.0, 0.45 cube. Okay, so this is x2 minus x1, 2.0, 0.35. Okay, let me write here, plus negative 3.0, 0.35 cube. Okay, so this is x2, this is x1, right? Bottom here is 0 for t2 minus 0.35. All right, use a calculator, calculate this out. This is average velocity from 0.35 seconds to 0.545 seconds. Okay, all right, so this is the first question. Second one, well, second one, the time interval will be smaller, right? So same idea, equal to x2 minus x1, t2 minus t1. So now t2 now is 0.41, t1 is 0.39. And on top, you figure out what is your position at 0.41 second, right? So 2.0, 0.41 plus negative 3.0, 0.41 cube, right? Minus, then same thing, you plug 0.39 into position relationship. Okay, so calculate this out. All right, so next one. At the starting gun, a runner accelerate at 1.9 meter per second square. Okay, so this is your acceleration. So you know A equal to 1 point, okay, time 5.2 seconds. And at starting point, a runner, starting point, okay, so this tells you that the runner start at 0. That's the velocity, 0 meter per second. And then after 5.2 seconds, the runner's acceleration is 0. Okay, so this is the first segment, right, from 0 second to 5.2 seconds, acceleration, initial velocity, and time, initial velocity, right? A, what is the speed of a runner at t equal to 2.0 seconds? Okay, so this motion asks you what is v. Well, so we use the equation here. It's v naught plus at, right? So we know v naught is 0, a is 1.9, t is 5.0. Okay, so this is the velocity at 2.0. No, I'm sorry. So this is 2.0, right? So this is at t equal to 2.0 seconds. So this is 2.0. So ask you velocity at 2.0 seconds. Okay, so this is 3.8 meter per second. Okay, so that's the first one. Second, what is the speed at the end of the race? Okay, so for this race, you see, you start with, if you look at the velocity time graph, right? So you start with 0, and then you velocity time, and you speed up with this 1.9 meter per second speed, right? So it's here, it's because this acceleration is constant, then velocity time is a straight line. And then after this is a 5.2 seconds. So here is 2.0 seconds. When you reach 5.2 seconds, you cannot speed up anymore. So after that, you move with a constant velocity. Okay, until to the end, whatever time here, right? So your speed at end of the race will be same as speed at 5.2 seconds, right? So V equal to V naught plus AT. So T here is 5.2 seconds. So this is 0 plus 1.9, 5.2. Okay, so this is the speed when you reach 5.2 seconds, and then you maintain the speed all the way to the end. Okay, so your end speed equal to the speed V end equal to speed of 5.2 seconds. All right, so this is the speed at 5.2 seconds. All right, so this will be yeah, so will be 9.88 meter per second. Okay. All right. Number 6. Starting from rest, a boat increases its speed to 4.82 meter per second with constant acceleration. Okay, so here what do we know here is V naught is 0 and final velocity equal to 4.82 meter per second with the constant acceleration, which means A is constant. Okay, what is boat's average speed? All right, so average speed, we have a couple of equations. Average speed equal to, okay, average speed. So average speed equal to half of that, right? So this equal to 0 plus 4.82 divided by 2. Okay, so this equal to 2.41 meter per second. Okay, and then if it takes about this much time to reach the speed, how far have it traveled? All right, so we know here we know that's the time, right? And then how far traveled. So displacement equal to average velocity times time. In this case, couple equations, right? We use this equation. So 2.41, 4.77. Okay, so this is 11.5 meter. All right. Okay, okay, number 7. Number 7 is a person on horseback moves according to the velocity versus time graph shown below. Find the displacement of the person for each segment of the motion. Okay. Well, so this is what we know here is the velocity versus time graph. Displacement. Displacement. Okay. Well, we know displacement, so this is velocity. Displacement is the area covered by VT graph. Okay, so for you look at the area. So for the segment A, so this is A, right? You look at this area. Okay, so for segment B, you look at this area. For C, you look at this area. You see area covered by, just calculate the area. Well, for the area here, this is a triangle, right? So A is triangle. So triangle here, this is 10. This is 2, right? So it's 2. So area here is, area for this one is 10 to half of that. Okay, so this is 10. 10 times 20 is 10. Area of this one, B, for B is you have 2 segments, 2 parts. You have this triangle, and you have this rectangle. Rectangle here is, this is 5, this is 2, so this is 10 area, right? And this one is, this is 5, this is 4, you see, from here to here. This is 4, from here to here, 4. 5, 4, 20, half of that, 10. Okay, so B is 20 meter, because 10 plus 10, right? So A is 10 meter. And the C here is, you see, you have this is rectangle, and you have triangle. Rectangle here is 15, 25 is 10. This is 2, right? So this is 20 area. This is 10, 4, 40, half of that. So this is 4, this is 10. So half of 44 times 10, half of that is 20. Okay, so this is 40. Okay, so number 7. So remember, velocity time graph. If you have a velocity, just like this, right? So velocity time graph, if you look at the distance traveled from 0 to t1, you just calculate this area. This area, because this is a curve, is pretty difficult to calculate. You have to use like a calculus to calculate this. But for the simple area, like a triangle, rectangular, and then rectangle, you can just directly calculate the area. Number 8. Number 8. As the train accelerates away from a station, it reaches a speed of 4.7 meter per second in 5 seconds, right? So accelerates away from a station. At a station, V naught is 0, right? So V equal to 4.7 meter per second, time equal to 5.0 seconds. Okay, if the train acceleration remains constant, what is its speed after an additional 5 seconds? Okay, so what happened here is from V naught is to 0, right? Then 5 seconds, you reach here. You reach V equal to 4.5 meter per second, right? Ask you another 5.0 seconds later, what is your speed? All right, so speed, we call this V1, V2. V2 equal to, because acceleration constant, V1 plus AT, right? You know T, you know V1, you don't know A. So where we get A? Well, we can get A from 0 to 5.0 seconds, right? So you see this one, V1 equal to V naught plus AT. Okay, so this is 5.0 seconds. So A equal to V1 minus V naught divided by T equal to 4.7 minus 0 divided by 5.0, right? So this is A. Then once we know A, we can plug A into here. So V1 equal to 4.7. This is another 5 seconds, right? And you have A here, plug this value to here, then you can figure out what's the speed after additional 5 seconds, 5.0 seconds. So the answer will be 9.4. So this is 4.7 plus, so this is 4.7 minus 0, 5.0 times 5.0, you see, right? So this is 9.4. 9.400. Okay, number 9. Number 9 is a rocket blasts off and moves straight up from the launch pad with the constant acceleration. Okay, after 2.8 seconds, Okay, after 2.8 seconds, the rocket is at a height 91. Okay, so um, straight up, right? Blast off. Okay, so here V naught is 0, and then after 2.0 seconds, 2.8 seconds, t equal to 2.8 seconds, rocket is at 991 meter. What is the magnitude of the rocket's acceleration? So here, what we know here is delta y equal to 91 time, right? And initial velocity. Okay, so how do we calculate acceleration? So looking for what is A. This is not free fall. You just like you have to propel rockets into the space, right? Okay, so A is a constant, but this initial velocity, all right? So we use this equation, delta y equal to v naught t plus 1/2 at squared, to figure out what is your acceleration, right? So v naught is 0, so this guy is gone, and a equal to, you see, 2 delta y divided by t squared. All right, so this is 291, 2.8 squared. So this is acceleration. Second, what is its speed at this time? 2.8 seconds, right? So what's the speed? So v, so what do we know here is we know initial velocity, acceleration, right? And the time. So v equal to v naught plus at. So v naught is 0 plus a, this is a, and times time, 2.8, right? So 291, 2.8 squared. So this is a, times time. Okay, so you calculate this out. All right, so, okay, just calculate this out. All right. Next one. A boat is cruising in a straight line at a constant speed of this. Okay, cruising, 2.6. This is cruising constant. Okay. When it is shift into neutral, shift to neutral. Okay, so now initial velocity is 2.6 meter per second. Then you shift to neutral. After it coasting 12 meter. Okay, so here, okay, 12 meter. The engine is engaged and the boat resumes cruising at the end at reduced constant speed of 1.6, right? So here, V naught equal to 2.6 meter per second. Then you shift to neutral, so you coasting, right? So V equal to 1.6 meter per second. All right, the displacement here is 12. That's all we know. Okay, A. How much time did it take for the boat to coasting the 12 meter? All right. Well, we can use this equation. Okay, in class I give you few equations, right? This equation is very more convenient. So delta x equal to v average times time, right? Average here equal to v naught plus v divided by 2, okay, times time. All right, so use this equation. Time equal to delta x divided by v naught plus v divided by 2, right? So delta x is 12. Initial velocity is 2.6 plus 1.6 divided by 2. Okay, so this is your time. All right. Second, this is A. What was the boat's acceleration while it was coasting? Okay. All right. Let me change. Okay, let me change. airport. Okay. All right. All right. So next one. Okay. So second one. What was the boat's acceleration? Why it was coasting, right? Coasting acceleration. So now what do we know here? From first one, we know time, right? We know time. How long it take from here to here? So acceleration. Okay. So here we know initial velocity, final velocity, and time. So equation we use here is v minus v equal to v naught plus at. So a equal to v minus v naught divided by t. Okay, so here's the time we already figured out, and then we can figure out acceleration. So because we know v equal to 1.6, v naught is 2.6, right? Divided by whatever times here. That's acceleration. Remember, this is negative acceleration. That's why you slow down. Okay. Third one. What was the speed of the boat when it had coast for 6.0 meter? Okay. So this one asks you about what's the speed here? Delta x equal to 6.0 meter. All right. So how do we figure this out? Well, use this equation. So v square equal to v naught square plus 2a delta x, right? So this is a 6 meter. A we already figure out. Right? So A is here, right? So this is A figured out, and then we know V naught, right? Well, just plug into this equation. Then whatever here is V square, right? And the V equal to square root of this guy. Okay, so that is your velocity, speed at 6.0 meter. All right, next one, 11. 11. On a hot summer day in the state of Washington while kayaking, I saw every swimmers jump from a railroad bridge into the Snohomish River below. The swimmers stepped off the bridge and I estimate they hit the water 1.5 seconds later. Okay, um, so this is a bridge. This is a bridge, right? And this is water. And you just drop from here. So basically it's a free fall, right? Drop and then time here equal 1.5 seconds. This is your y-axis, and then okay, I saw swimmer, right? So they reach the water 1.5 seconds later. How high was the bridge? Okay, so you start from here and here, right? So this is your delta y from here to here. So how high? Height equal to negative delta y, right? Okay, because you start from here and here, so this is negative. Displacement is negative, but the bridge you look at height, positive, right? So this is negative. What is delta y? Delta y equal to, you say in this case we know v naught equal to 0, right? V naught is 0, and this is free fall, so a equal to negative g. Okay, so delta y equal to v naught t minus 1/2 gt squared. So this is a free fall equation. So plug in, right? So negative v naught t minus 1/2 gt squared, right? So this v naught is 0. So this guy is gone. So negative, negative, positive, right? 9.81 t 1.5 squared. Okay, so this is the height of the bridge. How fast were the swimmers moving when they hit the water? So we look at velocity, right? So velocity equal to v naught minus gt, right? 0 minus 9.81, 1.5 seconds. and the velocity is negative value. But if they ask how fast, which means ask about the speed of the velocity. So you just whatever get here, you make it positive. Ask the speed. What would be the swimmer's dropping time be if the bridge were twice as high? Okay, so for this one, you see, we can tell h equal to, you see, negative, right? So equal to half gt square, right? So h equal to half gt square. Well, what if you double the height? H prime equal to 2h, okay, right? So what's about ask you about T2, right? T1, this is h, so h equal to half of T1, right? So h equal to half gt square. H prime equal to 2h, right? 2h equal to half gt1 square, right? Twice of that. This also equal to half gt2 square. Okay, so what's the T2? So you can tell half cancelled, right? So T2 square equal to 2T1 square. So T2 square equal to square root 2T1 square. So T2 equal to square root of T1, right? So ask you, what will be the swimmer drop time? So we know T1 is 1.5 seconds. So square root 2, 1.5 seconds. Okay, so this will be the time for T2. Because h equal to half gt squared, if you double the height, so h prime equal to half gt prime square, right? So if you double the height, you can, let's go another route, okay? So that's this way. So you see h prime over h equal to half gt prime square over half gt, right? So this is cancelled. So t prime square over t square equal to h prime over h, which is 2. Okay, so you square root on both sides. So t prime over t equal to square root 2. So t prime equal to t square root 2 times t. Okay, so that's the answer. And just time this out. Okay, last one. Okay, last one. A model rocket blasts off and moves upward with acceleration 12 meters per second. Okay, so blast off, V naught is 0, then you move with this acceleration 12 meters per second square, right? Until it reaches the height of 29 meters. Okay, so here is 29. All right, so this is moving with constant acceleration, which is a. So this rocket will pushed up by, propelled up by external force. At which point its engine shut off. Okay, so when you reach here, engine shut off, and it continues its flight in free fall. So from here, it's a free fall. All right, what is the maximum height from the ground? This is ground, right? So after you shut off the engine, then what happened for this rocket is just move up, right? And then come down. So we need to know what's the velocity when rockets reach this height. And this, then rockets will do a free fall with this initial velocity, with velocity, whatever here is this, right? Then how high you can go. This is h. This how high from here to here, right? So this is the peak. You reach a peak and then come down. Okay, so this is peak. What is the maximum height from the ground? Okay. Well, so you calculate, let's calculate from here, this location to the peak, then plus 29. That'd be the height, maximum height from ground. All right, so first, we have to calculate what's the initial velocity for the rockets to do free fall velocity here. But velocity here, we can figure out this, right? So we know delta y equal 29 meter, and then v naught is 0, acceleration, okay? So velocity here, use this equation. We call this v equal to v square equal to v naught square plus 2a delta y. You see, this equal to v naught is 0, 2, 12, 29. Okay, so v equal to 2, 12, 29. Okay, so that is speed here. All right, so this speed will be 6.4 meter per second. No, this speed, no, so this is not speed. What's this speed? 2 times 12, so this equal to 24, 29, let me calculate. Square root 2 times 12 times 29. 26.4. Okay, so this speed is 26.4 meter per second. All right, so this will be the initial speed, initial velocity for the free fall. Okay, at this point, right, when you reach this velocity, you turn the engine off. So this guy will still keep going up. So V peak, we know at peak time, at peak velocity is 0. And then you can calculate what time from here to the peak, from here, this location to the peak. Time peak, okay, equal to final minus initial. Initial here is this velocity divided by g. Okay, so we use this equation, v equal to v naught minus gt, right? So we can figure out t peak time. So this is 0 minus 26.4 divided by, let me see, t equal to, actually, so this equation gives you t equal to v minus v naught divided by negative g, so negative g, negative 9.81, right? So this is time to reach peak. Okay, and this 2.6. Okay, so how high you can go from this location? Okay, so delta y equal to v naught t minus half gt square, right? V naught is 26.4 times 2.69 minus half 9.81, 2.69 square. Let's calculate what it is. Okay, so 26.4, 2.69 minus. Okay, so this equal to 35.5 meter. All right, so this delta y is from this point, right? So here, this is a 35.5. All right, so the question asks you the maximum height from ground. So from ground will be 29. You have to add 29. Okay, so h equal to 35.5 plus 29, right? So this will be 64.5 meter from ground. All right. What if the speed of the rocket? What is the speed of just before it hit ground? Okay, so no, so it should be is. What is the speed of rocket just before hit ground? All right, so this is initial velocity, right? For the free fall, then move up, then come all the way down here. Ask speed. So from here to here, what we know here is delta y equal to negative 29 meter. You see? You look at the whole trip. From here, from the location you do free fall, then up and come all the way down. Ask you about the speed here. All right, so we know displacement. Initial velocity is 26.4. Okay, that's enough. So we use this equation, v squared equal to v naught squared minus 2g delta y. Okay, good enough, right? So v naught is 20 squared minus 2, 9.81, negative 29. Okay, so calculate this out. So negative, negative, you do the you do addition actually. And then v equal to square root of, right, 26 point square minus 2, 9.81. Okay, so that is your speed, right? Hit the ground. What is the speed? Ask you speed. Velocity, remember velocity, this guy is down, right? So velocity will be a negative. So when you do square root, you have positive negative, okay? Velocity will be negative. However, to ask you about the speed will be the magnitude of velocity, so which is positive. All right, so this is the assignment chapter number 2.